Hello friends and my dear students, I welcome you all to my channel. So this is part 1 of the next chapter uh, of which is 3D shapes, that is three-dimensional shapes, where I will discuss about what are 3D solids and what are the basic parts of a 3D solid, and we'll discuss about the parts of some standard 3D shapes or solids like cuboid, cube, cylinder, sphere and cone. So this video is part of the playlist CBSE Maths 7 for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my very basic and basic rough notes prepared for today's topic, which is about three-dimensional shapes or solids. Now, let me quickly check if everything is visible or not. Okay. So what are 3D solids? In short, I've written 3D, which stands for three-dimensional. So what are three-dimensional solids? Any object having a definite shape and size and that occupies a fixed space is known as a three-dimensional solid. Like for example, you have cuboid, you have cube, you have cylinder, you have sphere and cone. So these are the standard 3D solids that we will discuss in this chapter. So any object which occupies some fixed space, by fixed space it means that the amount of space it occupies, it does not change over time, or it does not change with time, or even if the object changes its position, that space that it occupies remains the same. And also the object has a definite shape and size, which means that the shape and size also does not change. Okay. Now, what are the basic parts of a three-dimensional solid? We have surfaces, or it is also known as face. Now, surfaces, as you can see, as you can understand, it's a surface, and the surface can be flat or it can be curved. Just like in a sphere, the surface is curved, but for a cube or a cuboid, all the faces are flat. So it has some faces or surfaces. Also, it has some edges. It can have one or more than one edges, and the edges can also be curved or straight. That is, an edge can be a straight line or a line segment, or it can be a curved line. And it may have some vertices. That is a point, a common point between two edges, or three edges. Now remember that any 3D solid will not have all these parts. So these are the basic parts that are mostly available in all the 3D shapes. But some 3D shape may not have a edge, or may not have a surface, or even may not have a vertices. Now let's discuss all these parts for cuboid, cube, cylinder, sphere and cone. Okay. So the first we have is cuboid. Okay. So what is a cuboid? So cuboid, as you can see, all the faces are flat. Now, and also all the edges are straight lines. And all the faces are flat. Okay. And there are many vertices, as you can see. So let's from the diagram you can easily understand that all the vertices in a 3D shape I will indicate by a dark circle. So point A is a vertex. Point B. So the points A, B, C, D, E, F, G, H, all these letters actually indicate the vertices, corner points. So for this cuboid, let's see what are the let's first understand what are the faces. let's see what are the faces. Now, what are the faces? We will label each face by the vertices. Now, if you consider this face, that is the top surface, this face is AB, AB, E, and G. So, let me quickly highlight the face. So, this is the top face of the cuboid, that is the plain figure ABEG, which is basically a rectangle, So this is a face ABEG. What are other faces? Now, the other faces are, it will be really difficult for me to visually apply because I'm not really used to with drawing. Anyway, so ABEG is a face. Now, the opposite face to this face ABEG, the opposite face, that is the bottom face of the cuboid, is another face, that is FHCD. This is the face opposite to the face ABEG. So we have two faces. We have ABEG and we have HCDF or FH FHCD. This is face. So we have two faces. What are other faces? Consider the face AHFG. So this one. So this is another edge. This is another face AHFG. Now it will have its opposite face. The opposite face to face AHFG will be this face, which is EDCB, is the opposite face to the face AHFG. Okay. So we have considered the top and bottom faces, and we have considered the face AHFG and EDCB. Now consider the face ABCH. Now it will be really difficult for me to visually understand. Now this face ABCH is another face. Its opposite face will be, now its opposite face is GEDF. I hope you will be able to understand. Now it will be very difficult to visually understand, highlight, mark the face GEDF, because it will be confusing. I hope you are understanding by the labels, by the plain figures of the faces that I am indicating, that is ABCH, the faces ABCH and GEDF are opposite to each other. So we have, how many faces we have considered? We have found 6 faces. There will be 2 more. How many faces are there in a cuboid? We have considered top and bottom face, and there will be 4. These are the top and bottom faces, and there should be 4 other lateral faces. Okay, so we have considered all the faces. So these are all the faces of the cuboid. Now let's consider the edges. Now you can see that 2 faces meet at a common edge. 2 faces meet at a common edge. So let's consider all the edges, and the edges for a cuboid are line segments. So let's say edge AB. Let's say the edge AB. Now what are its common, in the bracket I am writing its the common faces, that is the faces that meet at the edge AB, and those 2 faces will be ABCH and ABEG. So these are the 2 faces that are meeting at the common edge AB. Okay, let's consider the edge GE, and let's try to understand figure let's try to see what are the two common faces that are meeting at that are meeting that meet at this common edge GE. So the first one will be GE DF, and the second one will be, of course, ABEG. Okay, now, so this is another edge. Let's consider the edge AG. Now, what are the two common faces that meet at the common edge AG? One must be ABEG, and the other one will be AH and FG. AH and FG. Okay, let's consider the edge BE. BE, what are its common faces? That is the two faces that meet at the common edge BE. One must be AB, E, G. Now another one must be BC. We have where is the face? This face. How do I name it? ED, G, EDCB. Okay, so this face EDCB. These are the two faces meeting at the common edge BE. Okay, now let's consider the face, the edge BC. What are the two common faces that meet at the common edge BC? Of course, one will be EDCB, and the other will be, we are considering BC, so the other will be AB and CH. AB, CH. Okay, let's consider the edge CD. What are the two common faces of the edge CD? One will be, of course, HCDF. HCDF. Okay, so we have named it FH. FHCD is one face, and the other face will be EDCB. Okay, let's consider the edge FD. Now, I am quite sure you will be able to understand. You are quite sure you have understood what are the common faces of an edge. Anyway, just for the sake of completeness, I am writing down all the edges and what are the two common faces of an edge. So for the edge FD, what are its common faces? One obviously will be GEDF, and the other one will be at the bottommost face, which is FHCD. Now, how many edges are there? Let's see how many edges are there. We have FD. Now, let's say we have AB, we have GE, we have AG, we have BE. So the bottom face will the top face will have 4 edges. The bottom face will have 4 edges, and let's see FD. Let's say FH. For the edge FH, the two common faces are AHFG, and the bottom face, which is FHCD. Let's say consider the edge HC. The one common face will be ABCH, and the other common face will be the bottom face, that is FHCD. Okay, so we have considered, let me highlight all the edges that I have considered. We have considered AB, we have considered GE, we have considered AG, we have considered BE, we have considered BC, we have considered CD, we have considered FD, we have considered FH, we have considered HC. Okay, let's consider ED, the HED. Its common faces will be, of course, the rightmost edge, which is uh, EDCB, EDCB, and it will be the face which is facing towards us, that is GEDF, GEDF. Okay, so ED is considered. What edges are left? We have left GF, GF. Now for the edge GF, the one common edge is the leftmost edge, that is AHFG, AHFG, and the face which is facing towards us, that is ED, that is GEDF, GEDF. And I do not think there are, okay, there is one more edge, that is AH, this edge. Okay, AH. What are the two common faces of the edge AH? The face which is farthest from us, that is ABCH, ABCH. This is the common face, ABCH, and we have AHFG, AHFG, AHFG. I hope I have considered all the edges. So how many edges are there? Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I will quickly verify from the book. Yes, so there are 12 edges. So these are 12 edges, and we have already seen there are 6 faces. I hope there are 6 faces. Yes, there are 6 faces. Now, how many vertices are there? So vertices, it's very easy. The vertices are A, B, C, D, E, F, G, H. So how many vertices are there? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 vertices. Okay. So this is about a cuboid. We discussed about all the edges, all the faces, and which faces, which edge is a particular edge. It's common to faces and all the vertices. Now let's complete these figures. So these figures are important. That is, for a given solid figure or shape, what is the number of faces, what is the number of edges, and what is the number of vertices, if they have. So for a cuboid, we can see the number of faces we have counted to be 12. Okay, and the number of faces is 6. Number of faces is 6. Number of edges is 12, and number of vertices is 8. So this was, and also please note that a cuboid, how do we mention the size or the size of the cuboid? The dimensions, let me, the dimensions of a cuboid are specified by its length, breadth, and height. These are the 3 dimensions of a cuboid. Once you specify the length, breadth, and height, a cuboid can be drawn. Now you can consider for this figure, also remember that two opposite, okay, so one more thing, there are the lateral walls, the faces, okay, the faces A, B, E, G, no, not the faces A, B, E, G, the faces A, H, F, G, the faces A, H, F, G, and its opposite face E, D, C, B, and the other two opposite faces. These four faces which I have underlined are known as lateral faces. Lateral faces. It's like if you consider a room in a house, a room, the four walls are the lateral faces. The four walls are the lateral faces, and the floor and the roof, they are not considered as lateral faces. So cuboid has four lateral faces. It has six faces, in total six faces. It has 12 edges. It has 8 vertices. It has the dimensions of a cuboid dimensioned by length, breadth, and height. The two opposite faces of a cuboid are identical. That is, their edges are of same length. Their area is same. And yeah, that is it about a cuboid. Okay, now let's see what discuss about cube. Now cube is a very special case of a cuboid where the dimensions where is a special case of a special case of cuboid where the length, breadth, and height all are same. All are same. So as for the cuboid, for this cuboid, we can consider for this cuboid you can consider the length to be the edge FD. You can consider this as the length. For breadth, you can consider the line segment or the edge DC, CD. Okay, and for the height will be DE. Height will be DE. Now remember, DE is equal to BC is equal to GF is equal to AH. Similarly, FD is equal to HC, and you have DC is equal to FH, GE is equal to AB. Okay. Now for a cube, it is a special case of cuboid where the length, height, and breadth are all same. That is, here we will have ED will be equal to DC will be equal to GD. Okay. Now let's see what are the faces. Now since a cube is a special case of cuboid, we will definitely have the number of faces and the number of edges and the number of vertices exactly the same as a cuboid. So for a cube, the number of faces will be 6. As in the case of a cuboid, the number of edges will be 12 and the number of vertices will be 8. Now, since it is very similar to a cuboid, I am not really mentioning the edges and faces. It will take a lot of time. Only remember that it is a special case of cuboid where length is equal to breadth is equal to height is equal to height. That is, a cube is also is a special case of a cuboid. Okay. What else? Yeah, that is a cube. Okay. Now, what is a cylinder? Now, cylinder. Now, there are some examples from real life examples which resemblance like a shape of a cuboid. Now, for a cuboid, examples, real life examples of objects, real life examples of objects that have a similar shape like cuboids. You can consider a room, definitely a room. You can consider what else can be. I have to quickly check the book. Okay, a matchbox is a nice example. matchbox, a book, a book, any object that has length, breadth, the dimension of length, breadth, and height, and all the edges are straight, and all the faces are rectangular. You can also consider an almirah. So these are some real life objects that has a shape of a cuboid. Now cube, what can a cube be? Examples. Let me check. Is there any example of cube? There are no examples. Yeah, there are examples like okay. So real life examples. The real life examples can be sugar cube. That is why it is termed named as sugar cube. That is, the shape of the sugar is cube, like a cube. What else? A dice. What else do we have? Ice cubes. These are some real life examples. So there is nothing to discuss especially about a cube. It is the same as a cuboid, just that its length, breadth, and height are same, and it will have definitely the same number of faces, same number of edges, and same number of vertices, just as a cuboid. Okay, that was cube. Okay, cylinder. Now cylinder, it has three faces. Two faces. The F1 and F2 are flat faces. F1 and F2 are flat faces which has been shaded with a blue color, and there are two edges. They are curved edges, C1 and C2. If you consider the two blue regions, semicircular regions, like an oval, if you consider the circumference of each oval, that circumference is the edge. There are two oval regions, F1 and F2, and so their circumference, or you can consider them as an edge, and they are curved. So we have what do we have? Faces. Faces are F1, which is a flat face. F1 is a flat face. F1, it is a flat face. Flat. We have F2, it is also a flat face, and the face F3, it is a curved face. It is a curved face. Now, a real life examples of a cylinder. You already know the shape of a cylinder, and you already aware of real life objects that has a shape similar to a cylinder. You can say water pipe. What else you can have? You can have a straw. What else you have? Ice cream, not ice cream cone. Pillars. Circular pillars. It is named as circular pillars. Circular pillars. Circular, actually these are known as circular pipes, not water pipes, but it is circular pipes. Circular pipes, straw, I don't know, I'm not sure whether straw will be a good example or not, but circular pillars, circular pencils, and measuring jars, road rollers. Road rollers is a good example. So these are some real life objects that has a shape like a cylinder. So how many faces are there in a cylinder? There are two flat faces and one curved face. So there are three faces. Number of edges, there are two curved edges, C1 and C2. So in the figure, C1 is indicating the curved face for the C1 is indicating the curved edge for the flat face F1, and C2 is indicating the curved edge of the flat face F2. So number of edges will be 2, and there are no vertices. There are no vertices, because what basically is a vertex is that if two faces meet at a point, have a common point, and there is no such common point in a cylinder, so number of vertices is 0. So this is all about a cylinder. So the number of faces, number of edges, number of vertices, these are the main things that you must understand for the type of 3D solids that we are discussing. And how many, of course, how many curved faces are there, or how many flat faces are there. Okay, so this was cylinder. Next is cone. As you can see, the blue region, shaded region, is the flat surface. So cone, you already know what is a cone. Real life examples. The first thing that of course comes in mind is ice cream cones. Also birthday hat, not birthday hat, what it is called, a clown's cap, ice cream cones, and conical vessel. So these are some of the real life objects that has a shape similar to a cone. So what are the faces? A cone has two faces. The blue region, F1, it is a flat face. It's the shape of the flat face is like it's basically it's a circular flat face, and the other one is the curved face, that is the F2. This surface is curved, and there is a okay. I'm sorry for I forgot to write the edges for the cylinder. The edges are C1, which is curved, and there is another edge C2, which is also curved, and of course there is no vertices. Okay, for cone we have faces, two faces only. F1, that is the base of the cone, which is a flat surface or face having a circular shape. That is F1, and the other one is the curved surface F2. Okay, so number of faces is 2. Now edges, there is only one edge, which is the C. You can consider this edge C as the circumference of the flat surface F1. So we have number of edges 1, and we have also a vertex. This is the vertex. If you consider it A, vertices, the top point of a cone, that is the only single vertex A. So a number of vertices is 1. So the number of faces is 2, number of edges is 1, and number of vertices is also, number of edges is 1, and number of vertices is 1 for a cone. Okay. Okay, that was a cone. And the last one is a sphere. Now sphere is very simple. It's a sphere, as you know. It has definitely no vertices, it has no edges, and it has only one face, which is the curved face, So it's a solid sphere. So you can consider these. I'm sorry, maybe I'm demonstrating it in a very bad way, but this curved surface is the only surface. F is so faces is only one face, which is curved, and there is no edges, and there is no vertices. So real life examples for objects that has a shape like a sphere is there are many. A cricket ball could be, there are examples. given in the book, but you can consider not a globe. Let's say I don't know whether a cricket ball is has the shape of an exactly as a sphere or not, but there is a in the gym I see there is a medicine ball, which I hope is like a sphere. Medicine ball is a kind of even though yeah, a medicine ball could be an example. It is used in the gym. Uh, what else can we have? I'm not sure if the globe can be considered as a good example of a sphere, but anyway, so I hope you understood the all the standard 3D solid shapes and their faces, their edges, and the vertices, and only the thing that you must remember, not remember, understand very clearly that what are the number of edges, faces, and vertices for these standard 3D shapes, like which are sphere, cone, cylinder, cube, and cuboid cuboid. So that was all for this video. In the next video, I will discuss about net of a three-dimensional figure, which is a bit complex topic, and I will try my best to explain it in a best way I can, because competitive examinations are mostly based on mostly based on identifying the net of a given 3D solid 3D solid or 3D shape. So please stay tuned for the next video, which will be about net of a three-dimensional figure, and after that we will solve the problems of now these are not problems, these are basically based on information. You just need to know what are the number of faces, vertices, and edges, and to identify the net of a given 3D solid or shape. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Thanks for watching, and until the next video, take care and bye.